Hey everyone, welcome to week 3. We're our first lesson of the week. Our goal is to expand and simplify binomial products. We're going to start the lesson with a warm-up where I want you to calculate the volume of these two shapes here. And I want you to upload your working to OneNote, thank you. So in case you can't understand my drawings, this is a quarter cylinder. And this here is a prism with a small rectangular prism cut out of it. So a small square-based prism. So please take the time now to do those warm-ups to calculate the volume of those two shapes. Let's get to it. Today we're looking at binomial products. So a binomial expression, so we look at this word binomial, bi meaning two. So a binomial expression is one that has two terms. For example, x plus 7 has two different terms, so that's a binomial expression. X squared minus 3, x plus y, whatever. Any two different terms added or subtracted together, whatever, is a binomial expression. A binomial product is the multiplication of binomial expressions. Okay, so product means multiplication, binomial. So a binomial product is the multiplication of binomial expressions. So if we see a binomial product such as this below, a plus b multiplied by c plus d, we can expand this with the distributive law. Now you might have called the distributive law FOIL. FOIL stands for first, inner, outer, last, and it's really just a nice way to remember the distributive law. For example, if we focus now on this binomial product, we are going to expand that together with the distributive law. So we multiply the first terms together and we get AC. Then we add that to multiplying the outer terms together, AD. Then we add that to multiplying the inner terms together, BC. And finally, the last terms together, BD. And that's where that first, outer, inner, last idea comes from. If I do a short example here and I want to expand the expression x plus 1 multiplied by x plus 5, I can use that FOIL method again, or the distributive law, whatever you want to call it, it's the same thing. Our first terms multiplied together are x squared. Add that to x times 5, 5x, plus x, plus 5. Sorry, I've just gone over my working there. And then, guys, I notice I have some like terms. So I need to simplify that. I end up with x squared plus 6x plus 5 as my answer. So let's get cracking on some examples. So for example A, we have an x minus 4 term multiplied by an x plus 7 term. Let's expand that together. We get x squared plus 7x minus 4x. Now we have to be careful here because there is a minus sign here, so it's negative 4 multiplied by x. Take 28. Same deal, guys. You've got negative 4 times positive 7. We have the like terms here. So we end up with x squared, 7x take 4x is 3x, so plus 3x take 28. And that's my answer. Now be warned, in your exam or in your textbook, sometimes we just say to expand a binomial product, but we always want you to simplify. So even if that word simplify isn't there, this answer here is not adequate. You would need to have this final answer at the bottom with the like terms collected. If you would like to, pause this now and have a go at B and C. Otherwise, I'm going to get straight to it. So, first terms, 2x times x is 2x squared. 2x times negative 6, don't forget, is negative 12x. Negative 1 times x is negative x. And finally, the outer terms there, plus 6. Okay, now I've got plus 6 because it's negative 1 multiplied by negative 6. Awesome. Make sure we collect those like terms of the x's. 2x squared, take 13x plus 6 is my answer. Finally, we have a binomial expression here where both the first terms have a coefficient to x, so that means the number out the front of x. Let's start with expanding this, so let's do our first terms, 15x squared. Outer terms, plus 35x. Inner terms, negative 6x. And the final terms, or the last terms, take 14. And then bringing that all together, I've just forgotten my squared there, 15x squared. Plus, so 35x minus 6x is 29x, take 14 is my answer. So guys, in order to practice these, you're now moving to exercise 8A. So questions 2, 3 and 4, if you just do E, H and K of each of those questions, you'll get a range of questions from having 2 pluses in the brackets to having a minus and a plus, 2 minuses and also some coefficients. Moving on to question 6 and 7, and then of course our challenge problem, question 11, if you're up for it. If you have any questions,